The formulas of ionic compounds depend on the charges of the cations and anions in the compound. If the charges of the cation and anion are opposite, then they cancel each other out in a 1-to-1 ratio, so the formula is just 1 cation to 1 anion. However, if the charges aren't opposite, say the cation is +2 and the anion is -3, then you have to determine the least common multiple of the absolute values of the charges. The formula will have as many cations as necessary to attain the least common multiple as a positive charge and as many anions as necessary to attain the least common multiple as a negative charge. The overall charge of the compound will then be 0. The cation is always written first, and if more than one polyatomic ion is required in a formula, then the polyatomic ion is placed in parentheses. Let's look at some examples. Based on the charges of the cations and anions, see if you can determine the formulas for 1. Calcium carbonate, 2. Ammonium chloride, and 3. Aluminum oxide. Look at your periodic table and 3.2 from the text if necessary, and pause the video to figure these out. The first step is to determine the charges of the ions. Calcium is a metal with a constant charge of +2, capital C lowercase a +2. Carbonate ends in the suffix ate, so it is a polyatomic ion. On table 3.2 we see that it has a charge of -2. Carbonate is capital C, capital O subscript 3, -2 charge. Ammonium is not a metal, so it must be a polyatomic ion. On table 3.2, we see that ammonium has a charge of +1. Ammonium is capital N, capital H subscript 4, +1 charge. Chloride is a monoatomic anion, and its charge is -1, capital C lowercase l, -1 charge. Aluminum is a metal, and it has a constant charge of +3, capital A lowercase l +3 charge. Oxide is a monoatomic anion with a charge of -2, capital O, -2 charge. Looking at calcium carbonate, we see that calcium has a +2 charge and carbonate has a -2 charge. These ions cancel out in a 1-to-1 ratio. The formula for calcium carbonate is capital C, lowercase a, capital C, capital O subscript 3. Notice that although the charges were necessary to determine the formula, they are not written in the chemical formula. Ammonium chloride is also comprised of ions of opposite charges. Ammonium has a +1 charge and chloride has a -1 charge. Thus, these ions cancel out in a 1-to-1 ratio, and the formula for ammonium chloride is capital N, capital H subscript 4, capital C lowercase l. Aluminum oxide is made of ions whose charges are not opposites. Aluminum has a +3 charge and oxide has a -2 charge. The least common multiple for 3 and 2 is 6. 2 aluminum cations will give a charge of +6 and 3 oxide anions will give a charge of -6, so the overall charge will be 0. An easy way to get the formula for most ionic compounds whose ions aren't opposites is to switch the absolute value of the charge to the other ion as a subscript. This isn't changing the charge, it's just a simple way to obtain the least common multiple.